Hello everyone. Today we are going to talk about the last topic of this class, the rate making. The rate making approach covered by this exam is called the manual rating. Under this approach, risks with similar characteristics are grouped together, and the rates are calculated based on the estimated future losses of the group. The rating method does not use specific loss experiences of the individual insured to determine the premium. In this section, we will look into the first step of the manual rating approach, which is calculating the indicated overall average rate and the rate change. The subsequent step will be covered in a more advanced exam. Now let's talk about the essential objectives of rate making. Rates must cover expected losses and expenses. In other words, expected income, which includes both premium and investment income, must equal or exceed the expected losses and all expenses associated with doing business. This means that the rates must be adequate both on a per class basis and for the whole book. In particular, each cohort of policyholders should pay for its expected costs. Rates must make adequate provisions for contingencies. In addition to converting expected costs, rates should be high enough to cover unexpected costs. Rates must encourage loss control. Rates should be structured so that policyholders are incentivized to avoid risk. For example, many auto insurance companies give discounts for safe drivers, good students, etc. Encouraging lower risk behaviors also help improve society by reducing accidents and injuries. Rates must satisfy regulators. Regulators require rates to be adequate, not excessive, and not very discriminatory. They may refuse to allow a rate change if it's deemed to be inappropriate or based on subjective methods. Thus, it's very important for an actuary to support a proposed rate change with data and good documents. There are also non-essential objectives for rate making. Rates should be reasonably stable. A stable rate reduces skepticism among consumers. Insurers can utilize reinsurance to spread out the effects of large losses over time. Rates should be reasonably responsive to changes. Changes that have an immediate and permanent impact on rates, such as changes to rate regulations, should be adjusted for quickly. Rates should be simple and easy to understand. It becomes easier to promote loss control when policyholders understand why a rate would increase or decrease. Besides, a complex system is expensive to maintain and makes the product hard to sell to the stakeholders and senior management, regulators, agents, etc. Now let's talk about premium and expense. Premium is equal losses plus expenses plus profit. So there are two main categories of expenses to consider: loss adjustment expenses and other expenses. Loss adjustment expenses can be further separated into allocated loss adjustment expenses and unallocated loss adjustment expenses. So allocated loss adjustment expenses, ALAE, are expenses that are associated with a particular claim. It is, for example, lawyers' fees. So this lawyer's fee is paid for each claim. So it's associated with the claims. It will be different each time, each claim. Unallocated adjustment expenses are expenses that are not associated with a particular claim. For example, salary of a claim department manager. The salary would not change because of claim change. So that's why it's unallocated. Then let EV and EF be the variable and the fixed expenses respectively for a specific time period. So V stands for variable, F stands for fixed. The variable expenses ratio and the fixed expense ratios is V is equal EV over P. F is equal EF over P, where P is the amount of premium for the same period. Denote QT as the target profit and contingency ratios. Then the amount for profit and contingencies in the rate-making process, profit equal QT times P, where P is the premium. From this, we get a permissible loss ratio, which is the target loss ratio to cover variable expenses and to meet the profitability goals. Permissible loss ratio would be equal 1 minus V minus QT. So here it just basically it explains it just split everything into portions of the premium, a factor of the premium. V is a factor expense ratio for variable expense ratio, and QT is the target profit contingency ratio. So they are all ratios. Now let's talk about premium at the current rate level, extension of exposures. An exposure is the basic unit used to determine premium. This unit varies depending on the product and line of business. For example, auto insurers typically measure exposures on a per car per year basis. Therefore, a 1-year auto policy on 1 car represents 1 unit of exposure. A 3-year auto policy on 2 cars represents 6 units of exposures, which is 2 times 3. Then the extension of exposures method involves recalculating the premiums of historical policies under the current rate level. In other words, we take the rating characteristic of every policy from the historical period and use those characteristics to recalculate the premium at the current rate. That's what's called premium at the current rate level. Let's take a look at this example. Consider an insurance policy with 2 rating variables, gender and age, and the basis rates of 100. So gender has male and female for this purpose. Rate relative is 1 and point A. Age is under 25 or 25 to 65 or over 65. The rate relativity is 0.9, 1 and 1.15. From the table above, the base cell for gender is male and the base cell for age is 25 to 65. An insured who is male and age 25 to 65 will be charged the base rate, which is 100%. An insured who is female and over 65 will be charged 100 times 80 times 1.15 equal 92. So basically you see that the standard rate is 1, then the rest is you apply the factors, rate relativity factor based on gender and based on age to get the actual rate for the age group and for gender. Now consider the following rate change history for an insurance product with a simple rate algorithm. So this is in a table. It's a simple rating algorithm. Rate per exposure is different based on the effective date, and it has two class factors, three class factors, and three territory factors, which will be used to apply to the standard rate to get a actual rate based on that class and that territory. So the question is, what was the premium charged for a policy return on January 1st, 2015 with class factor Y and territory factor C? Since the policy was returned before any rate changes, the base rate was 300. The relativities were 1.2 for class factor Y and 0.8 for territory factor C. So the premium charge will be 300 times 1.2 times 0.8, which is equal to 288. What would be the on-level premium be for the same policy? The on-level premium is the value of premium after it has been brought to the current rate level. Use the most recent base rates and the relativity to compute the answer. So for this policy, the current rate level is 330, and the factors for Y is 1.3, factors for C is 0.7. So we use 330 times 1.3 times 0.7 because 300.3. So if we repeat this calculation for all policies in the historical period, and then based on this current year policy year, we will get the on-level premium we need for a rate. Now let's talk about premium and the current rate level using parallelogram. The parallelogram method involves calculating average factors to be applied to the aggregate historical premiums to make them on-level. These average factors are called on-level factors. This approach assumes that the policies are returned uniformly throughout the period. Since this approach uses average factors, it's less accurate than the extension of exposure methods. It's easier to demonstrate this method using an example, so consider the following example below. You are given the following overall average rate change for a company. Initial, no change. If its effective date is April 1st, 2015, 5%. January 1st, 2016, 10%. July 1st, 2017, negative 2%. The company only issues annual policies. Calculate the on-level factor for calendar year 2015, 2016, 2017, and 2018 using the parallelogram method. So let's go to the next page. So to find these factors, we use the parallelogram. So the first step, we determine the timing and the amount of the rate change. The timing and the amount of the overall average rate change are given in a table. Let's present this information in a diagram. So in 2015, the rate change started from April 1st, 15. So from April 1st, 15 to January 1st, 2016, that's when the first rate increase take effect. Then from January 1st, 2016 to July 1st, 2017, that's the second rate increase take effect. After July 1st, 2017, the third rate increase take effect. So the horizontal x-axis represent time, while the vertical axis y represent the percentage of policy earned. So the diagonal lines separate policies of different rate level groups. These rate level groups are labeled 1, 2, 3, and 4. Each square represents a calendar year. Since we know that the policy is assumed to be issued uniformly, so that's why you can use this method. Notice that the diagonal lines end 1 year after respective effective rate. This is because the policies are annual. In addition, note that policies returned before a rate change will remain their rate until expiration. For example, a policy returned on January 1st, 2015 will maintain its premium rate until December 31st, 2015. So the rate change on April 1st, 2015 does not affect policy return before that date. Your step 2 is calculate the cumulative rate level index for each rate level group. The rate level index is the overall average rate change plus 1. For example, a 5% increase has a rate level index of 1.05. Then the cumulative rate level index of a rate group is the product of the rate level index for this rate group and the cumulative level index for a previous rate group. For example, the cumulative rate level index for rate group 3 is 1.1 times 1.05, which is equal 1.155. This is because the policy in this group has gone through the rate increase twice. First in April 1st, 2015, and second one in January 1st, 2016. So this rate increase accumulated. The cumulative level index for each group is tabulated below. Basically, the next group is just the previous cumulative rate level index times the rate level index for that year. So 1.155 is 1.1 times 1.05. 1.139 is 1.155 times 0.98. According to this table, a policy return before any rate change should have its premium multiplied by 1.1319 to make it on level. In this case, 1.1319 is called the current cumulative rate level index. However, we cannot necessarily multiply all the earned premium by this factor. We have to watch for the fact that some policies are returned with rate changes. And the second, policy aggregated by calendar year may be returned at a different rate level. Okay, now for step 3, for each year, calculate the portion of premium that correspond to each rate level group. We will apply simple geometry to the diagram created in step 1. So, for example, in 2015, calendar year 2015, As you can see, the square is divided into two parts. Assume the side lengths equal 1. So the area of the palette corresponding to rate group 2 is 1/2 times 3/4 times 3/4, which is equal to 2.28125. This is basically calculating the area of the second group. What remains is the palette corresponding to rate group 1, which is 1 minus 2.28125, so it's equal to 0.71875. So in this case we are saying that for the policy issue in calendar year 2015, there are 71.875% belongs to group 1 and 0.28125 belongs to group 2. So if it's in group 1, you will gone through 3 rate increases, but if you were in group 2, you will gone through 2 rate increase. So repeat this calculation for the remaining calendar year. The results are tabulated below. For calendar year 2015, we got the number 0.71875 and 0.28125. For calendar year 2016, we have 3 groups. It could either be 1 or 2 or 3. And you see the number respectively. For calendar year 2017, it belongs to either group 3 or group 4. And for calendar year 2018, it belongs to either group 3 or group 4 too, but with different area. Now, step 4, calculate the weighted average cumulative rate level index for each year. Next, compute the weighted average cumulative rate index for each year. Multiply the weights from step 3 by their corresponding cumulative rate level index from step 2. So for example, for calendar year 2015, average will be 0.71875 times 1, because this much of policies will only get the rate, will not get the rate increase for the first year, but for 28.125% of these policies, it will go through rate increase, which have a rate increase of 5%. So your average will be 1.01406. For calendar year 2016, your average will be 0.13125 times 1 plus 0.46875 times 1.05 plus 0.5 times 1.155. So each area, each group will have different rate increase. That's why it will be applied different rate increase based on the area of this calendar year 2016. Perform similar calculations for calendar year 2017 and calendar year 2018, then we get the following table of average cumulative rate index level for all 4 years. So the step 5 is calculating the on-level factor for each year. The on-level factor for a particular year is the ratio of the current cumulative rate level index to the average cumulative rate level index for that year. As a reminder, the current cumulative rate level index is 1.1319. For example, the on-level factor for calendar year 2015 is 1.1319 over 1.01406, which is 1.1162. The on-level factor for 2016 is 1.1319 over 1.10094, which is 1.0812. So finally, we can calculate premiums at the current rate level by applying the on-level factor to the corresponding aggregate premium. For example, if the calendar year 2015 earned premium is P CY 2015, then the current year 2015 earned premium at the current rate level is 1.1162 times this P. So to summarize, the parallelogram method requires the following steps. 1. Determine the timing and amount of the rate changing. Second, calculate the cumulative rate level index for each rate level group. For each year, calculate the portion of premium net corresponding to each rate level group. And fourth step, calculate the weighted average cumulative rate level index for each year. Number 5 is calculate on-level factor for each year. Now let's look at example 1. You are given the following information. Company X made the following rate change in the last 5 years. So from May 1st, 2015, rate change is 3%. January 1st, 2016, rate change is negative 1%. And then July 1st, 2016, rate change is 5%. The calendar year earned premium for Company X are as follows. 2014 is 4,800, 2015 is 5,200, 2016 is 5,400. Company X only writes annual policies. Calculate the earned premium at the current rate level for calendar year 2016. So to solve this problem, first we want to draw a parallelogram. And based on the information, we can draw each areas based on the timing. Now let's focus on calendar year 2016. It actually has 4 areas. Calendar year 16, we can calculate the rate level for each of these rate group, and also calculate the premium portion of premium that calendar year 2016 that corresponding to each rate level group. So area A is a triangle. Based on this area of this triangle, we know the base is 4 over 12, 1/3. So the area would be 0.0556. A and B sum up to 0.5, therefore the area of B is 0.5 minus this 0.0556, so it's equal 0.4444. And the base and height of D both equal 1/2, so the area is 1/2 times 1/2 times 1/2, which is 0.125. And accordingly, we can find the area for C is 0.5 minus 0.125, so it's 0.7375. Note that the area must sum to 1 because we assume each square representing 1 calendar year. So then we get the following cumulative rate level indexes and the portion of calendar year 2016 premium for the 4 rate group. So you can calculate rate level, cumulative rate level index, which is just based on the rate level index. And you can also calculate in the portion, which is the area of each group in this square. So the weighted average cumulative rate level index for calendar year 2016 can be calculated as the cumulative rate level index times the portion and you sum them up, which comes out to be 1.022956. Next, calculate on level factor for calendar year 2016. Note that current cumulative rate level index is 1.07069. You divide it by the average cumulative rate level for calendar year 2016, which is 1.02956. So you got 1.03995. Therefore, the calendar year 2016 earned premium at the calendar year rate level is 5,400 times 1.03995. So it's equal 56115.72. Basically, this is a way to calculate the premium, estimate the premium based on the rate increase and the portions of rate falling in each group. So if we know the rate for earned premium for 2016 is 5,400, we know that it will become 5615 in calendar year 2017. Now let's look at the second example. You are given company X made the following rate change in the last 5 years. Effective date is May 1st, 2015, January 1st, 2016, July 1st, 2016, and which rate change will be 3%, negative 1%, and 5%. The calendar year earned premium for company X are as follows. 2014 is 4,800, 2015 is 5,200, 2016 is 5,400. Company X only writes semi-annual policies. Calculate the earned premium at the current rate level for calendar year 2016. So the tricky part about this question is that now the company X only writes semi-annual policies, which means the diagram you are going to draw is slightly different. So since policies are semi-annual, the rate changes are completely in effect after 6 months. In other words, the diagonal lines end after 6 months rather than 1 year. Note that the slope of the diagonal lines is twice as steep as the slope for the annual policies now. The diagram would look like this. The subsequent steps are identical to the one from the previous example with annual policies. Calculate the cumulative rate level index and respective portion of calendar year 2016 premium for each rate group. So then the weighted average cumulative level index for 2016 can be calculated to be 1.03502. Finally, the calendar year 2016 earned premium at the current rate level is 5,400 times 1.07069 over 1.03502, so it's equal 5,586. Now let's talk about the overall average rate change. Let PI be the premium, indicated premium for the forecast period. We know premium is equal losses plus expenses plus profit from previous lessons. So PL Pi would equal L plus V times Pi plus EF plus Qt times Pi, where V is the variable expense expressed as the fraction of the Pi, and similarly Qt is profit expressed as the ratio of the Pi. Solve this equation for the indicated premium, we can get that Pi would be equal L plus EF over 1 minus V minus Qt. Recall that the denominator is the permissible loss ratio from previous lesson. Depending on what data is available to us, there are two ways to proceed from here. We can either use loss ratio method or pure premium method, also known as loss cost method. If we use loss ratio method, let Pc be the premium at the current rate level. If we divide the formula previously have by Pc, we will have Pi over Pc will be equal this. Then eventually you will get this indicated average rate change will be equal Lr plus F over 1 minus V minus Qt minus 1. This is the formula we will use under the loss ratio method. As this method calculates the indicated average rate change from the current rate level, note that this formula uses LR, or the loss ratio, which is why it's called the loss ratio method. Alternatively, if we use pure premium method, we can let NE be the number of exposure. If we divide the formula by NE, we will have this. Then we will know the indicated average rate will be L bar plus EF over 1 minus V minus Qt. This is the formula we will use for pure premium method, also known as the loss cost method. This method calculates indicated average premium per exposure. It derives its name from L bar, the loss per exposure, which is also referred to as the pure premium or loss cost. Now let's look at this example to understand the concept. You are given the following information. Premium at current rate level is 120K. Projected loss and loss adjustment expenses is 74K. Projected number of exposures is 1000. Variable expense ratio is 20%. Fixed expenses per exposure unit is 25. Target profit and contingencies 5%. Current average rate is 120. Calculate the indicated average rate change under the loss ratio method and the indicated average rate under the pure premium method. So, apply the formula under the loss ratio method. The indicated average rate change is this 74K over 120K plus 25 times 1000. 25 is the fixed expense per exposure unit, but there is 1000 units, so it's 25 times 1000, and over 120K, which is a premium, and over 1 minus expense ratio is 20% for variable expense, and 0.05 for the target profit and the contingencies. So we got 0.10. Apply this formula under the pure premium method. The indicated average rate is 74,000 over 1000 plus 25 over 1 minus 0.2 minus 0.05, you got 132. So if we were to use the indicated average rate change of 10% to calculate indicated average rate under the loss ratio method, we would get 120 times 1 plus 0.10. That would be equal to 132. So eventually they are the same result. Note that in the example above, both methods resulted in the same indicated average rate. This will not be the case in general. For example, if the premium and the current rate level is calculated using the parallelogram method, there will be discrepancy between the two approaches. The evidence of this method depends on using the equivalent of this method depends on using consistent data and assumptions for both approaches. Now let's look at a real example. Page has been asked to calculate the rate change for annual policies effective October 1st, 2018. New rates are assumed to be effective for 1 year. Policies are assumed to be returned uniformly through the year. She uses the following ultimate losses to project future loss experience. An annual effective rate of 3% is selected as the loss trend. To match the loss experience, use the corresponding calendar year earned premium. So in the last 3 years, there have only been 2 rate changes. 3% on July 1st, 2015 and 5% on January 1st, 2017. Page calculates the earned premium at the current rate level using the parallelogram method. Page then calculates the loss ratio for each year and selects the average as the projected loss ratio for the forecast period. All expenses are variables, and she decided on a permission loss ratio of 80%. Calculate the indicated average rate change using the loss ratio method. So using the loss ratio method, the indicated average rate change is, the formula is LR plus F over 1 minus V minus QT, then minus 1. So LR is the loss ratio, F is the fixed variable, fixed expenses, but we know that all expenses are variable expenses, so F will be equal to 0, and the permissible loss ratio is 80%. Therefore, 1 minus V minus QT would equal 0.8. So our equation reduces to this LR over 0.8 minus 1. To calculate the projected loss ratio, we need to trend losses and bring premium to the current rate level. So our first step is to calculate trended ultimate losses for each accident year. Recall that we learned how to trend loss in section 5.2. Okay, we actually did not talk about this in detail, how to trend the losses, but we can learn from this example. First, calculate the average loss occurrence date for every experience period and the forecast period. Then calculate the trend period and trend the ultimate loss for each accident year. Note that the annual trend factor is 1.03. Okay, so this 1.03 comes from the information. An annual effective rate of 3% is selected as loss trend. Okay, so to trend this, we first need to determine the date. For accident date 2015, we use July 1st, 2015 as the date. This is because that July 1st is considered a midpoint of the year. So similarly, for 2016 and 2017, we always choose midpoint. Then trend 2 day is October 1st, which is in the given information. If we count it as years, we know this will be 4.25 years from July 1st, 2015 to October 1st, 2019. Similarly, for 2016 and 2017, we can get 3.25 and 2.25 years. And we can calculate the trend ultimate losses to be like this. First, 2015, you will have 917 from the beginning. And then 917 will be multiplied by 1.03 raised to the power of 4.25, which is equal to 1100. Basically, just look at that as the inflation rate. We just inflate these claims or losses based on the inflation rate and the year. So it's similar to what we learned in theory of interest. There is not much to talk about here. So yeah, after this we can get to the next page and talk about the rest. So step 2, calculate the earned premium at the current rate level. So in step 1, we calculate the trended losses. Now we calculate trended premium, basically. So first we draw a diagram and calculate the cumulative rate level index for each rate group. So first we calculate the cumulative rate level. So for rate level A is 1, rate level B is 1.03, rate level C, which go through 2 rate increases, so it's equal 1.03 times 1.05, which is 1.0815. Now we can compute the portion of the premium for each calendar year that correspond to each rate group. Then calculate the average cumulative rate level index. So for each calendar year, we see how many portion is, and we calculate the area for each rate level, and then utilize this area as the weight, and utilize the cumulative rate level index we just calculated, and to get the weighted average cumulative rate level index. I wrote out a formula here just in case you don't know how you get these numbers here. After that, you calculate the on-level factors and use them to calculate the earned premium at the current rate level. The values are here. I also give you the how to calculate these numbers. Basically, you use the 1.085, which comes from here, divided by this average cumulative rate level index here, then you get the on-level factor. You times the premium, which is 1000. Okay, step 3, compute the loss ratio for each year. So the loss ratio can be computed once we get the trended losses and the premium and the current rate level. Now step 4 is compute the projected loss ratio for forecast period as the average of the loss ratio. Step 5, finally, we can calculate the indicated average rate change to be this 0.8543 over 0.8 minus 1. Get here. So now let's look at example 2. Chip Insurance Corporation plans to expand its business by breaking into existing market with a new insurance product. The product is expected to be launched on April 1st, 2019. Annual policies are expected to be returned uniformly during the year. Cadem, an actuary in the company, is instructed to estimate the premium rate for the product. The rates are assumed to be effective for 1 year. He plans to use his industry-wide loss data to predict future losses. A loss trend of 1.5% per year compounded continuously is elected. So here it says the loss trend of 1.5% is compounded continuously is selected. So just to make this clear, when it says this, basically we are still using the 1.5% to compound the trend, the loss, but we are not using like 1.5 raised to a power of how many years. Rather, we use exponential to do this, as we learn in the theory of interest. So that's just one thing. We'll see the example result in the next page. Anyway, Cadence is told to include a variable expense provision of 33% and a target profit provision of 5%. A fixed underwriting cost of 25 is expected for each exposure. Calculate the average rate change for a new product using the pure premium method. So we know the pure premium method, the formula is as follows. We are given the V is equal 0.33, QT is equal 0.5, and the EF is equal 25. Therefore, we can get this. To calculate the projected pure premium, we need to change the ultimate losses. So step 1, calculate the average loss occurrence date for every experience period at the forecast period. So for accident year 2016, the average loss occurrence date is July 1st, 2016. For accident year 2017, the average loss occurrence date is July 1st, 2017. As we said, because this is the midpoint. Since annual policies are returned beginning April 1st, 2019, the average loss occurrence date for a forecast period is April 1st, 2020. Calculate the trend period and the trend ultimate losses. For accident year 2016, T is equal to 3.75. The trend ultimate loss is this loss amount. Here is what I meant when it says compound continuously. You use exponential to inflate these losses to get to this. Similarly, we calculate the trended ultimate losses here. Step 3. Next, calculate the pure premium for each year as the trended ultimate losses divided by the earned premium. For accident year 2016, the trended pure premium is this. And for accident year 2017, the trended pure premium is this. We know the formula is just premium over exposure. 1 to 800 is exposure. Step 4. Then the projected pure premium is the weighted average of the trended pure premium. Okay. So it's 0.4% for the first one, 0.6% for the second one. This information was given in the question. So step 5, finally the indicated premium per exposure can be calculated to be 640.14. Instead of trending the ultimate loss and then calculate the pure premium, we can also calculate and then trend the pure premium. Divide the ultimate loss by the earned premium exposure to calculate pure premium, then calculate the trended pure premium by applying the trend factor. The result will be identical. So this is just a different way to do it, but you will get the same result.